Hi, this is Anthony Carruthers from the Better Lesson Master Teacher Project, talking about how I show students the construction of a tangent from a point outside the circle. So this is not a straightforward construction, not one that I would expect students to come up with on their own. So I'm just trying to guide them through it and where possible, give them some room to think about what might happen next, but it's highly guided. So I'd start off by drawing a segment from B to C. So I will be showing students this whole demonstration. And then I would explain to students that this segment here, which I'm actually going to label, is going to be the hypotenuse of a right triangle. All right, so that's going to be important for us to keep in mind, that this is going to be the hypotenuse of a right triangle. And at first that might not make sense, but I try to make it make sense by drawing a diagram sort of like this. So I'm going to pick an arbitrary point on a circle, and then I'm going to make a triangle consisting of the center of the circle, that point on the circle, and then the point outside the circle. Okay. So at this point, I would ask students, have I drawn the tangent from C to this point on the circle, which is called G? And some may think it looks like it's a tangent, but as we've learned earlier in the lesson, the true test for whether it is a tangent or not is whether this angle here is a 90-degree angle. So on Sketchpad, if this were a 90-degree angle, it would give me the box to indicate that it's a 90-degree angle. So this, at this point, is actually not a 90-degree angle. And it makes sense that it wouldn't be, because I just kind of arbitrarily picked that point, and it would be highly unlikely for me to get it to be exactly 90 degrees. But at least now students should understand what our goal is. So we need to have a 90-degree angle there at G in order for segment CG to be a tangent segment. So once I give them some time to discuss that and make sure everybody understands kind of where we're going with this construction, then I'm going to backtrack and get back to our original situation where we just had segment BC. Okay, so we want to make segment BC a hypotenuse, and the thing is, how do we do that? So earlier in the lesson, we talked about a property of right triangles, and that is the midpoint of the hypotenuse is equidistant from the vertices of the right triangle. So we're going to use that fact here to help us with this construction. So I'm going to select this segment, which is going to be the hypotenuse, and I'm going to find the midpoint of that hypotenuse. Okay, so what I know now is that this point here, H, is the midpoint of this hypotenuse of the imaginary right triangle that's here in front of us. So again, thinking of the fact that this midpoint of the hypotenuse must be equidistant from the vertices, that means that the distance from H to C is the same as the distance from H to B, which is also the same as the distance from H to that point on the circle that I'm looking for. All right. So for the students, I would say, well, how do we construct all of the points that are the same distance from H as C is? So we want all points that are the same distance from H as C is. And so I'll give them time to think about that. So we know that actually that would be a circle centered at C, having radius HC. So when I construct that circle, that gives me all the points that are the same distance from H as C is, but I'm particularly interested in the point that's on circle B that's the same distance from H as C is. So that gives me two choices actually for where I could put that point. I could put it here, and I could also put it here. Okay, so Again, here for students, I would probably pause and just give them some time to discuss, ask questions, just to make sure that they understand what's happening and why we've done what we've done. And once that's taken care of, I'm going to go ahead and clean this up to get rid of the stuff that I don't need. So I'm going to get rid of this circle here. So let's just hide that. All right, and then from there, I know that the segment from C to this point here must be a tangent segment. So I can construct a segment or a line, but that should be a tangent. Now to test and actually see if it is a tangent, and to show students that it actually is, I'm going to make the segment from B to the point of tangency, so the radius to the point of tangency. And as we know, then that angle there should be a 90-degree angle, so I can measure it. And sure enough, that angle is exactly 90 degrees. Again, Sketchpad will indicate that with a box if we label the angle. So label the angle, and so by all accounts, we've successfully made a right triangle, which means that the radius is perpendicular to segment CI at this point I, which means that point I is a point of tangency and segment CI is a tangent segment. So at this point, students have seen the construction on Sketchpad. They still have to do the construction themselves on or using Compass and Straight Edge. So again, I'll have time for them to discuss overall what we did with the proof, to ask questions, and the next step would be for them to actually try the construction on their own. So hopefully this helps. Again, my name is Anthony Carruthers, Better Lesson, Master Teacher Project.